Hello guys, my name is Engineer Holiday. Today I'll be discussing resistive circuit under AC, which is lesson 2. Go and watch our lesson 1. Now, in this lesson 2, talk about resistive circuit. This is a resistance. So it's a circuit that has a resistance connected to an AC circuit or AC source. So this is a good example of it. This is a resistance or a resistor connected to an AC. There's a difference between a resistor and a resistor. A resistor is a component that resists the flow of current in a circuit, while a resistor is the ability of a resistor to resist the flow of current in a circuit. If I put a value on this particular resistor, it becomes a what? The resistance of a resistor. So I've explained that. Let's go on. Now, in this circuit, this AC resistive circuit, there are important facts that you need to get as a student before engaging yourself in an examination hall. Now, number one is that the current and voltage of this particular circuit are in phase. The current I and the voltage are in phase. So that means the current that is supplied by the AC, and this, don't forget, because this kind of circuit, we can also call it a purely resistive circuit. Purely resistive circuit. So when the current in this circuit, now current and voltage are in phase. And how do we know they are in phase? Look at this circuit diagram. This is how to know. You see, when you draw the AC circuit, AC waveform, this is what you are going to have as the circuit diagram. Meaning that the current and voltage all started from the same source at the same instant, so they are in phase. Now, number 2 point you need to note is that now we gave in lesson 1 that I, which is the RRMS or the instantaneous current, let me use instantaneous current, is equal to I naught sine what? WT. That is, this I equal to I naught sine WT. And if you check the waveform, it's a sine curve. What about the voltage? The voltage also has V naught sine omega t, because it is forming what? If you check the curve, also it's a sine curve. So the two of them, and both of them start from the same, from the point of the origin or the fixed point. Now, if you check this, the equation, this sinusoidal waveform equation that we have drawn or we have written on the board, you will discover that this one is sine, this one is sine. So that means that the current and voltage are in phase from what we have even written mathematically on the board. Now let us find the power. If you find the power, now power would be equals to what? I instantaneous current times I instantaneous voltage. This one we call instantaneous power. And since this one, the instantaneous current is already given as I naught sine WT, and instantaneous voltage is also has been given as V naught sine WT, we can place them in that power formula. Then we are going to have it as P is equal to what? I naught sine omega t, then V naught sine omega t. If you multiply it now, you have I naught V naught, then sine square WT. Now, there is something you must know. Now, in resistive circuit, the power has twice the frequency of the voltage and current. That's what we are saying now, is that if you plot the graph of the power, that means I naught V naught. Now you have a graph like this. Then you have something like this. Now let me just section it. Let me section it. so that you can see what I'm saying. If I section it, let me label this part. Let me label it. This part. Now, what I'm trying to show us now is that the power that is I naught V naught in the graph of power against time will produce sine square WT to be equal to half, because now this is sine WT. Sine WT, now if you check this graph from here, if you cut it from here like this up, you see that from here now, this is quarter, this graph here is quarter, this is also what? Quarter. Yeah. Quarter plus quarter will give us half. Half plus half will give us 1. Then that is for this one is for sine square WT. While for sine WT graph, which passes through the sine square WT, is half of what do you call it? Sine square W. So what we are now saying now is that this sine square WT can be likened to be equal to what? I naught V naught. You can replace it. It has a value of what? Half. It has a value of half, which is now equal to what? I naught V naught over 2. This is what we call the what? Instantaneous power, or we call it better, we call it average power. Average power. So that is average power. Recall that in the lesson 1, VRMS equal to V naught over root 2, and IRMS is equal to I naught over root 2. What is I naught? Maximum voltage over root 2, the maximum current over root 2. This is root mean square current, and this one is root mean square voltage. Similarly, mathematically, we can say that what? This one can be written as average power now, can be written as I naught over root 2 times V naught over root 2. Because root 2 times root 2 will give us 2. Therefore, we can now circle this one and replace it with what? With IRMS value current times what? VRMS. So if you don't have, if you don't see this one, the maximum current and maximum voltage in the question, you can also take this one as average power. Now, the power loss in a resistive circuit, power loss. Don't forget, power losses in or power expended, the total power expended in an AC circuit is caused by a resistor. Please take note of that. That question is common in professional exam and even in university exam. Even in JAM, the power loss, if you have a resistor, inductor, and capacitor in an AC circuit, they say which of these following components causes power loss in an AC circuit? The major component that causes power loss, that dissipate power in that circuit, is what we call a resistor. Now, and that power can be gotten by what? By average power of the circuit multiplied by power factor. So that is to say, in this case now, we are going to have it as IRMS VRMS cos phi. Power factor, please take note of that, is equal to cos phi. We call it power factor, PF. So if you see me write PF, it means what? Power factor. So power factor is equal to PF, and it's written majorly when we get to RS circuit. I will explain more about it. But take note of it, is cos phi. Cos phi, where phi is what we call the phase angle. So phi is called the phase angle. Please take note of that. Take note of that. So now, for what we have discussed so far, we can now conclude. We can arrive at the conclusion and say, point number 1, current and voltage are in phase. Current and voltage are in phase. Point number 2, power loss is caused by what? A resistor. power loss is caused by what? A resistor. 3. The phase angle between the current and the voltage is 0 degree. The phase angle between current and voltage is 0 degree. Then let me add one to it. What causes what? The energy stored or energy what is being dissipated. Each energy is being dissipated by a resistor. Each energy, that is what? I square RT is what? Dissipated by what? By a resistor. Then let's also note that resistor, according to Ohm's law, V equal to what? IR. According to Ohm's law, V equal to IR. Therefore, if V equal to IR, it then means that even a resistive circuit still obey Ohm's law. And the frequency, if you plot the frequency R against frequency or frequency against R, the line will be constant. That means it's going to give us a constant line. That is to tell you that what resistor is independent of frequency. I think at this junction I'll be able to explain and I'll be able to convince you, not to confuse you. I remain your humble engineer Holiday, a gentleman called Shortcut Master. Thank you very much. Ensure you subscribe and you follow us. Thank you.